Welcome, Class 12th. Let's jump right into this explainer. Today, we're taking some abstract economic math and turning it into a real-world superpower to uncover exactly how prices secretly control our buying habits.
Let's kick off with a real-world paradox. Think about this for a second. Why is it that if the price of salt suddenly doubles, we still buy the exact same amount, but if the price of air conditioners jumps, we just stop buying them entirely? Why do some price hikes completely change our behavior instantly, while others don't even faze us at all?
Here is our blueprint for cracking this open today. 1. What is demand elasticity? 2. 3 dimensions of elasticity. 3. The math behind the percentage method. 4. The 5 degrees of elasticity. And finally, 5. Factors affecting price elasticity.
Section 1. What is demand elasticity? The core concept.
Okay, so developed by Professor Marshall in his famous book, Principles of Economics, elasticity of demand is basically the percentage change in demand for a commodity with respect to a percentage change in any of the factors affecting that demand. The absolute key word here is responsiveness. Basically, how strongly does the market react when something shifts?
And because elasticity uses percentages, it's a completely unit-free measure. It doesn't actually matter if you're measuring demand in kilograms or tons or priced in rupees or dollars. It's brilliant because it lets us directly compare the price sensitivity of something super cheap, like a sewing needle, against something massively expensive, like gold.
Section 2. 3 dimensions of elasticity: price, cross, and income.
You see, demand doesn't just respond to a product's own price in a vacuum. There are actually 3 distinct dimensions we track. First up is price elasticity, which is the responsiveness to changes in the commodity's own price. Second is cross elasticity, which looks at related goods, how a spike in the price of tea affects the demand for coffee. And third, income elasticity, which measures how a change in the consumer's income impacts demand. All 3 definitely drive the market, but our primary focus for this explainer is going to be specifically on price elasticity of demand.
Section 3. The math, percentage method, translating behavior into numbers.
All right, let's slow down just a bit here. Because Class 12, this is the mathematical formula you will absolutely need for your exams. We start with a simple ratio, the percentage change in quantity demanded divided by the percentage change in price. If we expand that out, the top becomes the change in quantity over the initial quantity times 100. The bottom becomes the change in price over the original price times 100. When you simplify all of that down, you get the incredibly elegant proportionate method formula. That's delta Q over delta P multiplied by the initial P over the initial Q.
Now, there's one massive rule you have got to remember here. Ignore the negative sign. Because price and demand generally move in opposite directions, price goes up, demand goes down, your calculation is naturally going to spit out a negative number. But in economics, we just ignore that negative sign so we can focus strictly on the numerical value or the actual magnitude of the elasticity.
Section 4. The 5 degrees of elasticity: measuring the market stretch.
Depending on the product, this responsiveness falls into one of 5 specific categories. First is perfectly inelastic demand. This is represented by a completely vertical demand curve where elasticity, or ED, equals exactly 0. It's an imaginary situation where consumers buy the exact same amount of a good regardless of wild price changes. Price shoots way up or drops way down, the quantity demanded doesn't budge even a little bit.
On the exact opposite extreme is perfectly elastic demand, where elasticity is essentially infinite. Here, we're looking at a perfectly horizontal curve. In this theoretical scenario, infinite demand exists at one specific price. But if that price rises even a tiny fraction, demand instantly drops to absolute 0.
Now let's step back into the real world. For everyday goods, we usually compare less elastic goods to highly elastic goods. Less elastic or inelastic goods are things like salt or vegetables. The demand changes proportionately less than the price, giving us a steeper curve. Compare that to highly elastic goods, which are usually luxuries like air conditioners or DVD players. In this case, demand changes proportionately way more than the price, which gives us a much flatter curve.
To put that into perspective, with a highly elastic good, a 50% fall in price can trigger a massive 100% jump in quantity demanded. Because the percentage change in quantity is greater than the percentage change in price, our elasticity is greater than 1. The curve just stretches flat right across the graph.
I highly recommend taking a mental screenshot of this summary table right here. You have your 2 extremes at the top and bottom, perfectly inelastic at 0, and perfectly elastic at infinity, which, as we discussed, are largely imaginary. Then you have less elastic for necessities like salt, highly elastic for luxuries like ACs, and right smack in the middle is unitary elastic, where elasticity exactly equals 1. This is where a change in price leads to the exact same proportionate change in demand, which we often see with goods like scooters or refrigerators. Keeping this table in mind is an absolute game changer for your exam prep.
Section 5. Factors affecting price elasticity. The hidden rules of pricing. So what actually determines if a product lands on the inelastic or elastic side? Well, primarily, the very nature of the commodity itself dictates its elasticity. If it's a necessity required for survival, like food grains, we just can't avoid buying it. That makes the demand less elastic. It really doesn't fluctuate much. On the flip side, luxuries like DVD players aren't immediately required, meaning consumers become highly sensitive to price changes.
But there's definitely more to it. If you can easily swap a product for a close substitute, say choosing one brand of soft drink over another, your demand is highly elastic. If there are no substitutes, like for wheat, demand is less elastic. Also, think about the number of uses. Multiple-use goods like electricity are highly elastic because a price drop unlocks less urgent uses, like running an AC all day. And finally, postponement. If a purchase can wait, like a packet of biscuits, it's highly elastic. But if you have an immediate requirement, like a life-saving drug, your demand is incredibly inelastic.
We also have to factor in exactly who is doing the buying. Look at income levels. Higher income earners generally have less elastic demand. They just aren't influenced much by everyday price changes. Conversely, lower income groups who are budgeting carefully are highly sensitive to price changes, resulting in highly elastic demand for those exact same goods.
And of course, let's not forget the power of human behavior. Deep-rooted habits or addictions force demand to remain inelastic even when prices absolutely skyrocket. Then there's the share and total expenditure. Items that barely dent your wallet, like matchboxes or soap, remain inelastic because you're spending such a tiny fraction of your income on them. Finally, time plays a huge role. In the short run, it's hard to change your habits, making demand inelastic. But give consumers a longer time period, and demand becomes far more elastic as they find workarounds or new substitutes. I want to leave you with a final puzzle to test your new economic intuition. Imagine you're selling a brand new, life-saving medicine. It takes up a massive 50% of a patient's income, which points toward elastic demand. But it's an immediate necessity with absolutely zero substitutes, which points firmly toward inelastic demand. So, which factors outweigh the others in the real world? Think carefully about this, because mastering how these forces interact is the true secret to understanding economics.